Alright, here is our test review for direct variation and rational functions. So we're going to write the equations for these, we're going to find the constants, and then we're going to, constant variation, and then whenever we're done with that, we're going to find the missing value. So first things first, I'm going to label these as x and y. If variable m varies directly with p, those are my x and y's, and it varies directly is the one where we say y equals kx. So in this case, we're going to have m, which is my y, is equal to k, not x, p. So now we're going to have, if m is equal to 75, we're going to find k, and then p is 10. So this 75 and this 10 are tied together. That's why we use them in the same one. To get rid of this 10, to get rid of that 10, we're going to divide both sides by 10. So k is going to be equal to 7.5. So k is equal to 7.5. My new equation is going to be m is equal to 7.5 p. Then I plug in my missing value. Over here my missing value is 16. P is equal to 16. So m is equal to 7.5 times 16. Feel free to use your magic calculator. And we have 7.5 times 16, 120. Next one, we have indirect variation. Z varies inversely as P. So what I'm going to do, inverse variation is y equals k over x. Change my values. Z is equal to k over p. From here I can plug in the values I know. We're going to find our two that match each other. So Z and P, those match each other there. So my Z is 200. So 200 is equal to k over p, which is 4. So what am I going to do now? I am going to multiply by this 4. 200 times 4 is 800 equals k. There's my k right there. Once I get my k, I can take it and plug it into my equation. Z is equal to 800 over P. Plug in what I know. P is 10. So Z is equal to 800 divided by 10. So Z is equal to 80. That's how you do all of the math. The number of hours H it takes for a block of ice to melt varies inversely. So this is my, let's change color. This is my Y. H varies inversely as the temperature. So I'm going to use my inverse variation, which is Y equals k over x. In this case, that's H equals k over t. If it takes 2 hours for a square inch of ice to melt at 65 degrees, find the constant of proportionality. So what I need to do, I have my ones tied together. Plug them in here. So what I'm going to do is take my values here. My H is my hours. So 2 is equal to k over. My temperature is 65. From here I multiply both sides by 65. 2 times 65 is 130 equals k. All I'm doing is find the constant of proportionality, and that's what it is. But let's go ahead and make the whole equation for us. So I have H is equal to 130 over my temperature. And this right here, this 130, is my constant of proportionality. Or that one there. Next, we have a factory with a profit. Varies directly with the inventory. Direct variation, y equals kx like that. Change it the right way here, or to the match our problem. P is equal to ki. When pi, that one matches up. Let's plug them in. P is 100 equals ki is 20. To get rid of that 20, we're going to divide by 20 on both sides. 100 divided by 20 is 5. K is equal to 5. Now we're going to use this equation. We have P is equal to 5, because that's our new K. I. We're given I, so let's plug that in. P is equal to 5 times 50. P is equal to 250 for 250. That is my answer right there. That is the profit. In kickboxing, it is found that the force needed to break a board varies indirectly. So this is my force, sorry, my Y, varies inversely with the length. That is my X. If it takes 5 pounds, that's your force, to break a board that is 2 feet long, that is my length, how many pounds of pressure will it take to break a board that is 6 feet long? Inversely, so we're going to use Y equals K over X. You can fill the rest out, do the rest for yourself. Okay, now we have standard form of a rational function. Explain how changing the following values affect the graph of the function. I'm going to do this verbally, so I don't have to write all this stuff. And that way you can't just copy my key, you have to do something for yourself. Okay. A is this number up here. A is what we are going to multiply. This A value we've talked about for all these functions does the same thing. The numbers will vertically stretch or vertically compress depending on their size. So if the number is bigger than 1, it's going to stretch it out. It's going to be a vertical stretch by that number. If the number is less than 1, it's going to be a vertical compression. Then we look at the value, if it's positive or negative. Positive means nothing really, it's just a normal function. If it's negative, it changes where they are. So if these are, this is where the original graph is, a reflection switches. So if it reflects, it does that. So A is a vertical stretch or compression. If it's bigger than 1, it stretches. Lower than 1, it compresses. And if it's negative, it reflects it across the X. H shifts it left and right. And remember, it is opposite. It is opposite. K, outside, again, vertical, shifts it up and down. Alright, I'm going to do one of these ones on the bottom. I'm actually going to do A, not B, because A is harder than B. Well, it has more steps at least. I can't do anything with this right now because it's not in this transformation form like this. This is standard form. It needs to be put in standard form. To put this in standard form, we divide it. The top goes in, the bottom goes out. We look at the first terms. How many times does this X go into this X? That's going to be 3 times. 3 times x, 3x. 3 times negative 2, negative 6. Once I get to this point, I have to change the signs. So now I'm going to say that is minus 3 plus 6. Negative 1 plus 6 is 5 plus, and those cancel out. So I have my remainder 5 over x minus 2 plus my constant. This is my function. So let's list the transformations. Transformations. The a value, just like we talked about up here, is vertical stretches and compressions. 5 is a vertical stretch by 5. The negative 2 down here is a shift right. Remember, it goes opposite 2. And this plus 3 is a shift up 3. Now let's do vertical asymptote. And with the vertical asymptote, let's also do the domain. Vertical asymptotes are the ones that are up and down, just like this. That's controlled by this one right here. This whole thing has shifted over to the right 2, which means my vertical asymptote is at x equals 2. That's this number down here. That gives me a vertical asymptote. Remember, it's opposite here. My domain then is all real numbers except x cannot equal 2. Because there's an asymptote there. Horizontal asymptote. And then the range, they are matched up together. Horizontal asymptote is defined by this one. That plus 3 means my asymptote has moved up 3, along with the rest of the function. Y equals 3 for horizontal asymptote. And that means my range is all real numbers except y cannot equal 3. You gotta figure out this one for yourself. Doesn't require you to divide, it's just ready to go as it is. Okay, this one you're just matching the functions. There's 4 equations here, 6 options. Let's go ahead and just do one. Let's look at the bottom one. Basically, you're going to match your asymptotes, and then some of these might be reflected, so they have to move up where they are. Let's look at this one. This right here says it's shifted 3 to the left. Which of these is an asymptote where it's 3 to the left right here? Of course, that one doesn't have it. This one has it right here. No. This one up C has it right here too. That works. That one doesn't. That one. So it has to be C or E. Look at other asymptote. 3 up. Nope, that's not shifted up. This one is shifted up. So that is going to be C. Just a quick reminder, since all of you are paying close attention to me, if this was a negative 1, this line right here would be moved up here. And this line up here would be moved down here in reference to the asymptotes. They'd be shifted across that x-axis. Okay, couple of word problems. Mr. Wynn is having a party and is checking prices for catering. He found one company, all for one, that charge one set amount for catering. The company requires a minimum of 25 guests and a maximum of 250 guests. The following table shows how much it would cost per guest based on the set fee from the company. How much is it cost per guest if there are 175 guests? What are we doing? Okay. So how much is it cost per guest if there are 175 guests? So let's go ahead and let's find out whatever this equation is. cost per guest. Hold on, let me just check this real quick. 25 times this is going to be 2750. Alright, so to the next one, if we have 50 guests times 55, that's going to be actually the same thing. If we have 125 times 22, that is actually the same thing. And if we have 200 times 1, 3, that is also the same thing, 2750. Okay, hold on. Okay, let's finish up number 8. How much is it cost per guest if there are 175 guests? So, if our total cost is 2750, we're going to divide it among our 175 people. So that's going to be 15.71. What would be the cost per guest? The maximum number are invited. Maximum number is 250. So we're going to take 2750 divided by 250, and that's going to be $11. Write a function to find the cost per guest given the number of guests, G. So my cost is going to be equal to 2750 divided by the number of guests. So on the, I mean, it's that simple. It's not changing. Usually when we've studied these in class, this goes up. If there's more guests, it's going to cost more. You still have to pay for the people. It's just a little bit different than we looked at in class. D, on Monday 40 people had signed up. By Friday 55 people had signed up. How much did the cost per person decrease from Monday to Friday? So 40 people. We're going to find the cost. So we have 2750 over 40. That's the cost for 40 people per person for 40 people. And by Friday, 2750 divided by 55. You can put those in the calculator, see what it equals. I don't know what it is. Y'all can do that yourselves. Because this is the cost per person for 40. This is the cost per person for 55. Alright, here we go. Here's one that has an interesting or better cost per person situation. Planning a big birthday party for her sister's graduation. She can rent a banquet hall for $225 and spend $6 for dinner for each person. With this information, Anna used the equation here to calculate the cost per person if X people plan to attend the party. If Marshall waits until different times of the year to have the party, the price of the hall and the dinner change. Write equations based on the original equations given the following information. The price of the hall increases to $270. Well, the $270 is this initial fee up here. C would be equal to $270 plus 6x. Oh, I'm sorry. And the amount of the dinner doubles, that means this right here, so that's 12. And that's still going to be divided by the number of people coming. the prices of the hall decreases, C is equal to 50, and the dinner amount increase by 1, so that goes to 7x all over x. Number 10, I'm not going to do on the video, write it down for y'all. This is this right here. Should be pretty straightforward what the domain and range are. Again, it's all the domain and range is all real numbers except where the asymptotes are. $11 is a very fancy way of saying what has an asymptote at y equals 3. As the values of x approach infinity, the value of x approaches infinity, that's going this way forever and ever and ever and ever and ever. So that's an asymptote, a horizontal asymptote at 3. So which of these has a horizontal asymptote at 3? Could be that one, that one, that one, that one. They all have 3's in there. Horizontal, that's an asymptote looks like this, moving up and down. What would move the asymptote from 0 to 3? This B right there. Last page. Do some of these. There are 250 ounces of Star Power vitamin drink made in a batch. The company needs to determine how to calibrate the machines to disperse the drink into its bottles. The machine can hold between 10 and 40 bottles in a run. What is the function of E to find the number of ounces in each bottle given the number of bottles? Okay. Number of ounces in bottles given the number of bottles. So the number of ounces in each bottle is equal to the 250 that's made in a batch divided by the number of bottles. It's a pretty straightforward one. It doesn't change or increase when the ounces don't increase or anything like that when you add bottles to it. I'm not going to complete the table. Y'all can complete the table on your own. Domain and range y'all can do on your own. Here you're going to use, if you want between 7 and 12 ounces. You could probably look here, and I bet that would be there. So ounces would be here. Where's 7? Where's 12? And how many bottles would you need? Ooh, I'm sorry. This is the function. This is Math World. This domain range is based on our 10 to 40 bottles. Starting number here to here is our domain. Starting number here to here is our range. Situation right here. Start to finish. Vertical and horizontal asymptotes, you guys should be able to find those. 13, 14, express each function in transformation form. That means you divide it and write the horizontal asymptotes, domain range, and then graph it. I've already done one of these earlier, so I am done with this video.